Okay, before we start Lab 4, what I wanted to show you is a little bit of important information that's going to help us out with Lab 4 and also projects later. And we saw before, if we click on this negative sign here, code folds things up to make things a lot easier. One thing that we didn't really highlight, and it's interesting for bigger projects later, is you'll see with green dots here, all the different functions that you're working on. And if you want to get to that code quickly, especially if you're doing larger projects, you can just double click on the function name and it brings it up and it allows you to actually work with it. Now, one of the things that I've done here is I've added the word volatile to unsigned char value. The reason for that is if you don't have the word volatile for individual variables such as char, integer, or long, then it will not actually have it show up as a variable in the debug screen, so you won't be able to follow it through, and you'll have to follow it through the CPU registers, which isn't exactly the simplest thing to do because we're used to more of debugging using actual variables. So let's take a look at our debug screen. Here's our code. So as we start tracing through it, when we get to here, you're going to see under variable here, let's just zoom in a little bit, you can see that we have value. And right now it shows as double quotes because what it's showing is the default of how we want things to be done. So what we're going to do is we're going to right mouse click on here and we're going to go to format, and instead of using default we're going to say hexadecimal. So when we go back and take a look at this, we can see that it's showing up as 0x00, which is kind of cool. But it would not show up at all in the variables here as value and show us what the value is in variable or value without us having declared it as volatile. And it even tells us the physical address is 87D, which is kind of handy. It has everything that you want. Now before, what we did was we ran our program, we looked here under core registers and followed the value as it went through the accumulator. And that was all fine and good, but for most programs, what we want to do is actually just take a look what the variable is, take a look at it here, and get an idea of what's going on. So let's take a look at some other aspects of this. So as we start tracing through, and we're into the update function, it says value equals SWL. Now if you're tracing at home, you don't have the real hardware, so we're going to go to address 0, and let's just again bring this up to 1 byte here. And let's make this 16 columns so it makes it a little easier to see. So there's address 10, 11, 12. Now this one is SWL. So if we double click on here, we can actually put in a value like AA. Now notice it's green. We have to hit enter. Now it's going to know that the AA is there. So if we watch value up here as we start tracing through, we're going to see that it actually is taken, let's go a little bit closer here, it's taken the AA that we typed in here and it's now putting it into variable value, and it's going to work it through here. You'll also see again in registers that it also has it in accumulator, but we don't care about that. We're going to be more or less looking at values here. So again, the way to change this is to right mouse click, format, and make sure that you're looking at everything pretty much in hexadecimal instead of default. So these are the important things that we have to understand before we take a look at Lab 4, but let's follow this through a little bit more. Let's just trace through and see what happens. Now it says lead red low gets value, and you can see over here that it just changed this. And as we go through here, you're going to see that hex 3, if we take a look over here, we're going to see hex 3 is going to also change to AA. But one difference between the simulator and reality is when you pump the AA in here, it reads back as 00. So we can actually work with it a bit and get an idea, yeah, that's how our program's working and everything's going using the simulator. It's not the best, but it's the best we can do at home. And not only can we now compile our files, but we can also do a little bit of checking of how things should work. Now that we understand that, let's take a look at Lab 4, bit manipulation, arrays, and functions. And one of the things we'll see is there's a number of things here where it says A equals SWH and so forth, and an if based on that. So we're going to be dealing with that in the theory class, either before or after the lab. So in the lab, we're more focused on writing programs that do things. So the first program that we want to write is just involving two arrays, one called Bob, where element 0 is AB and element 1 is CD. And the whole concept is here we want to take an other array which has just garbage values in it and change the first element, which is element 0, from AB to BA, and the second element from CD to DC by flipping the digits. And we're going to be using the greater than and the less than symbols in C to do this, as we'll see. And that's what we have to show. And we can do this in the simulator because there's nothing here that involves LED, switches, or anything of that nature. Now, to create this program that we need fairly quickly, we're just going to say File, New, Bareboard Project, and go through all the normal stuff that we were doing before. We're going to say Lab4, we're going to say Next, we're going to say HCS08, GB32 under the G family, as we've done in the past, and Next, and we want the simulator for sure, Next, and C. And the only thing we're going to change, as always, is going to be minimum startup code. Now, when it creates this, one of the things we're going to do is we want to make life a little easier for ourselves. We don't want to have to type in everything in the kitchen sink if we can modify code that already exists. So we're going to be using not what I call the lazy person's way of doing things, but the efficient person's way of doing things. So what we're going to look at here is if we bring up main.c here, we just have the default code. But if we take a look here under this main.c, we have a lot of stuff already pre-done for us, including a programmer's block and an include section header. So let's just control C this, and let's make our life a little easier. Let's go back to the other main.c, and actually we can flip back and forth between these. Let's just move up a little bit, control V this in. Now this is a little different. This is not Lab 3, so we can change this to Lab 4, and this has to do with logic functions, and this program is flipping hex digits is basically what it's doing. Our name hasn't changed, your student ID and course hasn't changed, today's date might change, but what we're going to do is take a look back at the description in Lab 4 and put that in here. So let's grab again everything from here to here, right mouse click and copy, and let's go back and let's erase this and just control V on top of that and do a little bit of cleanup. So we're going to just put that back over there like so. We're going to tab this over a little bit, maybe not quite so far, there we go. And once we get it cleaned up, we have, with just a little bit of work, we've got a pretty neat little description going on here, and we haven't really spent a lot of time doing all this typing, especially if your typing skills aren't the best. So I'm just going to tab this over, and that's pretty much what we need for our programmer's block there. And we've got our include section here, and the other thing we want to do is get rid of some of these lines. Now if we want, we can go to full screen mode just by double clicking on this. Let's hit this over like this. Let's get rid of all of this stuff here, and we're going to replace all that with SOPT underscore COPE equals 0. And the comment that we're going to put on here is disable COP, the computer operating properly. So we've already got a fair chunk of our code done. Let's go back and take a look. Some of the other things we need. Now we've pretty much got everything we need from this project here, project 3. So what we're going to do is we're just going to right mouse click. Instead of deleting it this time, we're just going to go down and close it. So if we go down here, we can go to close project, and it's still there if we need other stuff, but right now it's not going to interfere with what we're working on now. Now the other thing we want to do is we want to put on here variable definitions and stuff like that. And where are we going to get those? We're going to get those from here again. So we're just going to, isn't this neat? Programming by cutting and pasting, cookie cutter programming. So we're going to copy this. Now there's a little bit of changing we're going to have to do when we get it in here. But before we do anything, you have to understand in C, this is not C++, this is not Java. In pure C, where do you put your variables? Before your first executable statement or after? Does it matter? And the answer is you bet, it does matter. Variables come first. Boom, boom, boom. So we're going to paste in our variables here. Now, some of the things that are going to cause errors, because it's a formatting thing, is we're going to have to bring this back a little bit, close this up. There shouldn't be spaces in here. So now we have our variables defined. So our actual executable code should come after disabling the computer operating properly. So above computer operating properly, disabling will be our variables. After that will be our actual code. Now we're going to take Fred, and the first element of Fred is going to equal, and let's put this in brackets, Bob of 0. And if we shift that left 4 times, so AB, if we shift it left 4 times, is going to be B0. Now, if we add to that, Bob is 0 again, but in this case, what we're going to do is we're going to, let's put brackets around this as well, round brackets. What we're going to do is shift this the other way, 4 times to the right. So if we shift Bob 4 times to the left, as we said, that's B0. If we shift Bob is 0 4 times to the right, that's 0A. If we add the 2, we get BA out of AB, and it works for any numbers we want. So isn't that kind of cool? Now, I like to be efficient. Efficiency is the height of laziness, so what we're going to do is try and be efficient as we can, because the second digit, we're going to be doing exactly the same thing. We're going to be taking Fred of 1 is now going to be Bob of 1, shifting this way, and so forth. And the last thing we have to do is make sure that our code never goes past this last curly bracket. And the reason for that is we have in our code, if we look here, we have void main void. In most of your programming in the past, you've done integer main void because you're returning a 0 back to an operating system. This is your operating system. Whatever code you put in between these brackets is your operating system, and it should never allow to get past this bracket by any other means. So that's why we have to have it sitting here in an endless loop, so it cannot get past here, because we're just executing 2 lines of code, and then we want to give it an infinite amount of time to see what is going on. In other programs, we're going to be looping around like we did in the past program in Lab 3, where we're going to be grabbing switches, doing some stuff, displaying it, grabbing switches, and so on. So these are the 2 types of structures. Either way, we have to have an endless loop somewhere. Now let's go back and go back to our other view, and we're going to compile this like we did before. So we're just going to click over here and say project, build project, and we want to make sure that there are no errors in our code before we go to the debugger. And once we get all this done, we're going to be running this exclusively using the simulator. We do not need the LEDs and switches and all those other things. We just need to have the thing in the simulator. So we're going to say run as Codewarrior, and we're going to pick the simulator because we don't need LEDs and switches if we're just manipulating things around in an array. So once we get to that point, we're going to be looking at some interesting things in our debugger. As we talked about right at the start, we're going to be taking a look at setting up variables and looking at things going through variables. And notice there's nothing here that says volatile, because arrays will not need to be declared volatile. They will show up in your area with no problem and be able to be debugged and looked at in memory, because there is no problem doing that. So let's take a look in our simulator. And it's just taking a little while to load here. It's launching the simulator. And here we are. Okay, when you go into your debug screen, and if you happen to look at variables up here and open them up, you're going to see that there's a default, which is sort of a char kind of thing. So what you're going to have to do is click here, hold down the shift key, click at the bottom, right mouse click, and format to be hexadecimal. If you do that, and once you've done that, the next thing you want to do is say Window, Save Perspective As, and copy it over to side Debug, because basically what you want to do is to always show these in hex, because that's the easiest way to see what's going on. Now what we've done here is the next thing we're going to do is trace, and we want to do always is go up here to Step Into. So as we step into, let's take a look at what's going on here. Let's back up just a little bit, and I've gotten rid of, just for convenience sake, I've gotten rid of the screen here that was the disassembly screen. I'm also going to get rid of the memory browser because we don't really need it, and we're going to then trace through here, Step Into. Now right at the start, and let's see if I can just move over just a wee bit here, just a little bigger over here. As we start tracing through here, you'll see that the AB has now been put in, so the AB has gone from here to here. And as we continue to step into, we're going to get the CD. And if we want, we can just hit, let's just back up a little bit here, we can hit the Resume. Now the Resume is going to leave you in a mode where you can't see anything over here. So what we're going to do is we're going to go here to hit Suspend, and there's all your values. And this is exactly what you need. AB, CD becomes BA, the digit switched, CD becomes DC. That's good enough for an initial. Okay, now for the next initial, what we need to do is consider the following variable Sam and array Sally. Now Sam has AB. What we want to have is Sally, the first element will be 0 and the first digit here. And the other element of Sally will be 0 and the other digit. And we have to write the code to do this. Now the code is very similar to what we just looked at, except we have an array. And notice we've got the word volatile in here. We have to use the word volatile so we'll see it show up in the variables list. Now what we're going to do is shift this. We're going to take Sally of 0 is going to be basically AB shifted to the right 4 times to get 0A. That's how we're going to get it here. But also 0B, you could shift it 4 times to the left, 4 times to the right, but then that's a lot of code in the background. So the better way is to AND it so that you get rid of the A by ANDing it with 0F, and that's what we're going to do to create this next program. Let's see how we go about doing that. Okay, every time we're going to create a program, we're going to create a project, because the project includes headers, settings, and all that for each one. So we're just going to do the normal File, New, Bareboard Project. I'm just going to zip through this quickly. And we're going to call this one Lab4B. Now if I had been thinking, I would have made the first one Lab4A. We're going to say next, again HCS08, G family, GB32. Next, we want to use a simulator because we don't really need the hardware for this one. C program, next, and again minimum startup and finish. Now to save ourselves a little bit of time, most of the code is very similar to what we have in the Lab4 project. It has almost the same code. So what we're going to do is we're just going to copy all the code from Lab4 into the Lab4B. So notice here there's main, which is our original Lab4. Here's main.c, which is our other one. So we're just going to go back here. We're going to do a Control A, Control C. Then we're going to go here, which is this guy. We're going to do a Control A and a Control V. And this has most of the kinds of things that we need. Now it's flipping hex digits again, but the description is going to be a little different. Now that we've got everything we need from the Lab4, we're just going to right mouse click and we're going to go down to Close Project, and then we just have our file that we need here to work with. So let's go back to our thing and see if we can find the description. We'll program, here we go, and there we go. Control C. Actually we can just do right mouse click, copy, and let's go back to our program and let's change this description again. The date maybe hasn't changed. Control V. And again, we just need a little bit of cleanup, but it's a lot easier than typing all this stuff. And let's tab over a little bit here and bring this back to the previous line and tab this over. whoops, back a little bit. And let's bring this over again, tab, 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 and back up just a bit, and so forth. So we, even with doing a little bit of work, it's a lot better than typing for those people that are slow typists. So we have our new description, and our data this time is different than the data here. So again, let's go back because we're lazy, efficient, that's it. And so we're going to take these descriptions that we've got here, and again, it's a little tricky at times to get this just right. So if it's not working too well on that screen, just make the screen a little bigger. And let's try grabbing that again. And again, it's not being all that helpful, but let's get over to here, right mouse click, copy, and let's go back over to here. And let's take out our variables that we've got now. Let's just take these out and Control V the new variables in. And again, Sally, we're going to have to bring this back a little bit. Doesn't matter about that. So everything is pretty much ready to go. So now we have Sally and Sam instead of Fred and Bob. So let's get rid of what we have in here. And if you think about it, all we really need to do is say Sally square bracket 0 is going to equal Sam, whoops, and we want 0A, right? So that's going to be shifted to the right 4 times. And we need Sally. I should have been more efficient and actually just copied and pasted Sally. And that's typically what you want to do with variables, especially if you have long variable names. Now we want to AND this with 0x, 0f. So that's what we really want to do. So that's our entire program there. So we've got our nice description, everything, and it didn't take that long to create all of this program that's here. Now we could have, gone full screen and so on. I just zoomed in to do this. So we've got everything we need. So what we're going to do is click over here, project again, build project. It's been modified, yes. Now we can call it other than just main.c. We can save it as Lab4B, Lab4A, whatever, and keep the .c files a little different if you want. And so we built our full file, and we have our binaries over here. So we're going to debug as Codewarrior. And again, we're going to launch the P&E full chip simulator. Now, once we go in, we're going to have the same kind of variables. And again, we can show this to our instructor fairly quickly. Okay, one of the things you want to do again is when we look up here is to change these variables. Now, don't type over here, but slide over here, grab, go from here, hold down the space bar, or not the space bar, sorry, the shift key, click here, and highlight the whole thing, because if you try it over here, it's going to give you some crazy messages. And again, we're just going to say format hexadecimal. Now, to get the initial for this one, what we're going to do is, again, what we can do is just hit this guy, and then hit suspend. And let's open this up and see if it's done exactly what we want. Let's just zoom in here a little bit. And this is again what you're going to have to show your instructor, is that AB becomes 0A, 0B, and Sally of 0 and Sally of 1. So that's your next initial, and you can call your instructor over and get that. Now, when you're working with this, you can, if you ever do anything like terminate, you're going to have to redo it again. But let's go back and see what you're going to do. So what you have is you've got Lab4 that you've closed and you can reopen it again. You can go down here, open project, and you can show your instructor one right after the other of each of these. You can go to this and bring this one up. You can then go to this one, bring that up, and show them one right after the other and get as many initials quickly as you can. Now, when we take a look at lab number 4 on question 5 here, it says write a program that will take bit 3. Now, if you remember, this is bit 0, bit 1, bit 2, so the 4th switch from the left. And basically, it's going to be used to turn on and off bit 6 of the green LEDs. Now, the leftmost one is bit 7, so the second from the left LED. So that's what this program has to do. Now, the thing is with LEDs, you can't just store a number. You can't just store, in this case, I guess it would be 40 or 00, because what you're going to do is the LEDs can be used to indicate status, like a motor on or off, a heater on or off, a fan on or off. So we could have 3 or 4 of these LEDs used as indicators, and we don't want to change that. We just want to change just this one LED without affecting any other LEDs. So let's keep that in mind as we continue on. Now what I've done here is I've closed Lab4, left Lab4B open, and created Lab4C. And if we take a look up here, we've got the 2 mains. We've got the main from 4B, and this is the main for 4C, and this has just got the default code. So what we're going to do very quickly is copy and paste stuff back and forth from here to the other file to get started. So what we're going to do is just grab what's here, the programmer's block, and save a little bit of time. And we can actually, if we really want to, go all the way down to here if we want. Let's Control C. Let's go over to the other one, and we will actually just highlight down to where we actually selected before, down to here, and let's actually down to here if we really want, and Control V. And so what we have here is a whole program with programmer's block, and at this point, to save a little bit of space, we're just going to go down here and we are going to close this project. So once we've closed the project, to make it a little bit easier to manage, and as you're doing things for your instructor, you can reopen projects and do everything from here, but we've got a lot of the stuff we need. Now if we want to take a look at changing this programmer's block, this is Lab4. It's no longer flipping digits. What it's doing is controlling bit 6 green lead by which one was it, bit 3 switch. So that's what our program's doing, and what we can do if we want more of a description, we can actually take a look at what's going on here and grab it. So program that will take, so we can actually copy from here, and again we can just right mouse click, copy, and let's go back. And again we'll have to do a little bit of cleanup, but we'll just paste that in, and I'll clean it up and then I'll come right back to where we are. Okay, now that we've cleaned this up, what we're going to do is we're just going to double click here to make it go full screen. Now if we have variables, they're going to come first, but what we're going to do in this case, which is a little different than the last one, is we're going to set up a forever loop. And we're going to be grabbing the switches, deciding whether or not to turn on that green LED, and so on. So this is our main program loop, and there's no way it's ever going to get out of here because there's no condition for it to terminate. Now what we're going to do is we're going to use an if statement, and we're going to select out the specific bit, which is bit 3, SWL, and we're going to add that, and there's a couple ways to add it. We can add it in binary, or we can add it in hex. I'm going to use binary, and everywhere where I put, so 0B for binary, everywhere I put a 0, it's going to mask out the effect of that switch. So we don't want 7, bit 6, bit 5, bit 4, but we want to have bit 3, but not bit 2, 1, or 0. And the way this is going to work is quite simple. And let's just put in here, and go down here, and let's put in an else. And again, some more brackets. So basically here's how our code is going to work. If SWL ended with this, so if bit number 3, this is 0, 1, 2, 3, if this switch is on, then it's going to generate something that's not 0 because all the other bits are set to 0. But if in case that this is 0, then it will do the else part. So there's 2 logic levels, 0 and not 0. The not 0 case will do this statement, the 0 case will do this. So when the switch is on, it's going to do this. Bit 3 switches on, it's going to do this. When the bit 3 switches off, it's going to do this. And then you have to ask yourself, well, what is it we want to do? Now we don't want to affect any other switches, so we're going to say LEDG equals LEDG, and then we're going to OR that with a particular binary value. Now every place where we put a 0, not affected. So we're going to say 0B. So 7 isn't affected, but we want to turn on 1, and we want to not affect any of the other bits. So that's what we're going to do. We're going to turn on LEDG. So that's what we're going to do here. And if you think about what we've just done, then the opposite is the case that we want to do down here. We want to get rid of or shut off this LED. Now there's two ways to do this. This is one way. Let me just write the other abbreviated way, LEDG pipe equals or ORed with, and then the same number. Now I'm a little bit on the lazy side, so let me just grab this here, Control C. So either one of these ways of writing this code is fine. This is a short form of this. This is saying LEDG equals LEDG ORed with this. This is abbreviated form. So what I'm going to do is, I like the abbreviated form, so I'm just going to get rid of this. And down here, what we're going to do is LEDG and equals, which is saying LEDG equals LEDG ANDed with, and then we want to shut off that specific bit. Now a 1 does not affect anything, a 0 will shut it off, and all the other bits here will not be affected. So there's our program there. It seems kind of weird at first that if this generates a 1, actually it's not a 1 case, is it? It's going to generate either 08 or 00. If it generates a 08, it does this statement. If it generates a 00, it does this statement. So what we're going to do is we're going to actually just take a look at running this code and seeing what happens. Now to save time, what I've done is I built the program, and after I built the program I ran the debugger, and basically we are doing this as P&E Multicyclone Pro. So what we're going to do is we're going to go up and we're going to trace through our code and see how well it works. Now I'm just going to grab this and make this a little bit bigger so we can see what's going on here. So I'm going to trace through. So as we start tracing, right away it's getting down here. Now notice all of our switches are off. So because all of our switches are off, it's going to go down here, and even if the LED is off here, it's going to turn it off. So I'm just going to trace again. And this time I'm going to turn on all the switches, just to show you, except this one. So I'm going to turn all the switches on except for this guy, and it should actually go again back down to here. So as I trace around, I'm going to flip this switch up, and I'm going to put all these ones down, and you should see that the green LED will be selected, and it will indeed, as we can see, come on without affecting any of the other LEDs. Now usually if I just go here to resume, let's just focus in up here, if I hit the resume it should actually just run the program, but notice it drops out again, and notice what it's doing here. It's doing init startup, and every time I hit this, oh my god, it's going back here, it's not allowing me to run the program. And you're saying to yourself, what the heck is going on? I said this myself because I forgot one simple thing. Can you spot the simple thing that I forgot to put in here? Yeah, I'm hoping you did, because let's go back here because it's a very simple fix. What did we forget to put in after variables comes first? SOPT underscore COPE equals 0. And why is that important? Because if we don't disable the watchdog, it's going to disable our program. So let's say disable COP. So we've learned the hard way. So I'm just going to go back here, and we're going to rebuild the project and say yes. And this is something that's going to happen to you at least once. And we'll pick it up once. I'm going to terminate and build. We'll pick this up once we get back to the debug screen and show that indeed it will work and we work properly. Now with this one little thing fixed, let's go back up here. Let's go up to the top here. What we're going to do is right at the start, and this is what you can do with your instructor, is when you're up here, just hit the resume button. And what you should see is this thing should continue on. You won't have to pause or anything. And right now, if we watch here, just turning this on and off, so not that one, but turning this on and off will affect only this bit. And that's what you need to get this initial on your lab. So don't forget SOPT underscore COPE equals 0, because tracing the program will work perfectly, But when you try and run it, it keeps stopping because the computer operating properly circuit will shut down your code because it times out. Now the next program we have to write says write a program that will take the LSB switch of SWL, and basically what it's going to do is turn on bit 1 and turn off bit 0 if it's high, and do the opposite if it's low. Now let's take a look at the coding. Now what I've done is I've closed Lab4C, opened this up, copied stuff over, and actually copied and pasted in here a detailed description of program that we'll take. So all the stuff that you just read is in here. So if we understand that, let's take a look at the program that we've got. Let's just bring it up here. And we can modify the original program. So basically what we're saying is if SWL, and what we're looking for is the LSB being high. So what we're going to do is make this 0, 0, 0 and then put a 1 at the end here. Let's just make sure we don't have too many bits. Let's see, 0, 1, 2, 3, 4, 5, 6, 7. So we had one too many bits. So this is going to check to see if the LSB is high, it's going to do this. If the LSB is low, it's going to do this. So what we're going to have to do is basically, if it's high, let's take a look. If it's high, it's going to turn on bit 1 and turn off bit 0. So let's see. Turn on bit 1. So what we're going to do is make this a 0, and this is 1 here. So that's what it's going to do there, but we've also got one other statement in here that we're going to say LEDG and equals to shut off. And let's see, 0B, not affect, 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 turn it off. So that's what these two are going to do. So it's going to turn it on, turn this bit on, and not affect any other bits with the OR. It's going to shut this bit off and not affect any other bits with the AND. And that's going to do what we want here. So again, we can't just load and store a number. We actually have to do this kind of stuff that we're doing here. So in this case, we're going to do the opposite. We're going to not affect any bits except this guy for the AND. And let's put in the OR. Let's go back here because we're a little bit efficient here. Let's be efficient. Control C. And let's paste in, well, right up above here, let's paste this in. And basically what we're saying here, whoops, let's slide down, is that we're shutting this one off, but we want to turn on the other one without any effects. So we're just going to basically hit this and put a 1 here. So what this is doing, where there's zeros, no effect. Where there's a 1, it turns it on. Where there's a 1, no effect. Where there's a 0, it shuts it off. So this is basically what we should have, and it should work. So let's give it a shot and see what happens. Now what I've done so far is I've done a build, and I've done a debug as Codewarrior and P&E Multi-Cyclone Pro. So at this point we should be able to just go up here as we've done in the past and just hit this, and as long as we've got our SOPT, which we have here, it shouldn't be any problems. I'm just going to run it. Let's take a look and see what's going on here. So if I press this up, I get this on, flip this, so I actually have it flipping back and forth, which is basically what I wanted to do. So just changing this, changing any other switch has no effect, just changing this up and down, that changes this on and off, which is kind of cool. And that's what you need for your next initial. Now on page 55 of chapter 2, there's a program that will put a pattern on the 7-segment displays, and it says to modify this program so instead of the most significant 4 switches, the least significant 4 switches will change what's going on. So let's take a look at that. First of all, here's the program on page 55. Notice what it does. It says program to put digits 0 to F on the 7-segment displays, and it's going to put it on hex 3. Now we have to change this to be hex 0 for our code, but that's not a big deal. But notice what it has here. It has an array called unsigned char segs, and it doesn't have any values in here. And what you have to do is put those values in. Where do you get those values? Well, you get these from Lab4 when you created this and filled in this table of values here. So those are the table of values that you're supposed to put in to the code here. Now let's see how this works. What it's really saying is hex 3 is going to get, now remember this is a pattern for a 0 here, pattern for a 1, pattern for a 2, and so on. What this is doing is says take our 8 switches, shift them 4 times to the right, which is going to generate a number from 0 to F, because if you had AB it's going to be 0A, if you have 3C it's going to be 03. So it's going to generate a digit from 0 to F, which is going to look up the array. So if this happens to be a 3, it's going to look up the pattern for a 3 and put it on hex 3. It's kind of cool. So what I've done, let's just switch over to Codewarrior. What I've done is I've actually taken and changed the title to be the same as the description and added all these things in. One of the things, if you're copying things, don't forget the double quotes. That can give you an issue, so make sure you change it to proper double quotes. And what we're going to do is we're going to compile this and run it and see what happens. So let's go to our debug here, and I've already set everything up. I've already got it ready to go except for the run part. So I'm just going to say run here, and it's going to do its business here of setting everything up. And then as soon as it's ready to run, let's see how this stuff works. It's really quite cool. So let's watch on our video what's going on. So as I start flipping these switches, so if I have all 4 switches down, I get a pattern for a 0, or the pattern for a 2 if I flip this up. So it goes 1, 2, 3, 4, 5, 6, 7. So you can go through all the combinations right up to and including F. So what it's doing is taking these 4 switches and putting it on the left 7-segment display. What we want to do is modify this so it takes these 4 switches and puts it on the right 7-segment display. That's all we really have to do. Let's go back to our original code and let's go full screen so we can take a look at it, all of it here. So we're going to change this from hex 3 to hex 0. And these again are all the codes that you should have looked up. Now notice I've got some of these wrong. This one should be 9E. It said to make all these even numbered. And this, instead of 99, should be 98 and so on. So you can change these to whatever. But because the dot is not really connected. Now instead of taking SWL and shifting it, if you think about this, what we want to do is just strip off everything but the lower 4 bits. So we're just going to say 0B, get rid of, get rid of, get rid of, get rid of, keep, 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 keep. So whatever SWL is, it's going to mask these off, and again it's going to generate a number from 0 to F based on our lower 4 switches. So let's run that up and see what we get. So right now I've done everything. I've done the build, I've done the run as, and basically everything's up and running now. And you'll notice these 4 switches here are sitting at 0. That's why the pattern for 0, pattern for the 1, pattern for the 2, pattern for the 3, and so on. So you can go through all the patterns from 0 to F and make sure that that chart that you created back when is actually valid. And when you take a look at this chart that you've got here, if everything's been filled in properly and these are all the proper numbers, everything should work. So that's actually killing 2 birds with 1 stone. Now the last program we have to write is on page 57 of chapter 2. When we go to chapter 2, one of the things you might want to do is zoom out here to actually be able to copy and paste the whole thing. So once you've done that, let's take a look at what it looks like in Codewarrior. And what I've done is I've done a lot of cleanup here. I put in title, author, and I put in all this stuff here. Don't forget again the double quotes. Now we'll find later there's going to be an issue right here that we're going to have to deal with. So there are some problems. As we take a look down here, it talks about, and let me just zoom in here a little bit, it talks in here about possible loss of data, and that's a warning. Now one other thing that it will give you an error about here, and it's got this I here, and it says the condition is always true. In other words, value less than or equal to 65,535, when you have value as an integer, every number is less than 65,535 or FFFF. So that's going to be an infinite loop, and we're going to have to deal with that later. For now, let's just back out here again. And what I've done already is I've got it ready to go. And what you're going to see, and you'll see these warnings come up if you say project build, and we build a project, and let's go back to um, this view here as it's running. And what we're going to see when it's finished the build, now I've done this before, but if we zoom in down here at the bottom, it does have those same warnings here, that if we open this up, it says possible loss of data because we're shifting 12 times, and it also will say condition is always true. So it will give you warnings, even though you can see those warnings in the code itself. And what we're going to see now, I ran the code before, so you see some default numbers sitting up here. But when it starts to run the code here, it's going to start off again at 0 and count up, and it's counting up at a certain pace. And that pace is based on, as we scroll down here a little bit, it's based on this thing here, the amount that's going to waste time. And right now we're using a number of 10,000. Now I'm going to go back, edit the program to make this 10,000 a 10, and then we'll see some of the issues that we were talking about earlier. Okay, what I've done here is I've changed the 10,000 to 10. I've done a build, and what I'm going to do is I'm just going to run out to debug here, and I'm going to go run and just hit the run option that's here. So right now it's doing a bunch of stuff up in here, and look at it counting. Now notice this digit here, it's going to go 6, 7, 8, and it's not going to get past 8. It should be A, B, C, D, E, F. And notice it starts over again at 0. So this is an issue. So let's just see what is causing that issue. You cannot, let's bring this up full screen, you cannot just say integer. If you say integer, what's going to happen is it signed or unsigned? So one of the things we have to do here is put in unsigned integer value, and again unsigned integer value, because sometimes the compiler will make it actually signed, and that's what it was doing. It wasn't going beyond what it should do. So just changing that from integer to unsigned integer should make it work. Now one of the things that it's asking us to do on the lab is don't start at 0 and count up. Let's start at 65,535 and count down. And one of the things you'll find is if we say greater than or equal to, and let's get rid of the 65,535 here and make this a 0, that's again going to be an infinite loop, and what we have to do here is a minus value. So what we're going to have to do is treat it so it's not greater than or equal to 0, but greater than 0. And that means that this is no longer going to be an infinite loop and just continue on. And what we're going to have to do is when it drops out of the loop, we're going to have to deal with doing one last thing. We're going to have to display 7 one more time, because if you remember, if you're counting through a loop and it says greater than 0, it's going to drop out of here. It's going to have a 1 here, and then it's going to come down here and have a 0 when it drops out. So what we're going to do is we're going to actually want to display the 0, and once we've displayed the 0 here, after it drops out of the loop, what we want to do is then sit here and wait forever. And that's exactly what our program should do. Okay, what I've done is I've done a build of the project, and I realized that I'd made an error here. I put too many 5s. But the nice thing is that once you do, and you've done the first thing of setting up that it's P&E Multicyclone Pro, you can just go here to run, and you can just say run or debug. I'm going to go to debug, and I'm going to say yes. And what it's going to do is it's going to do some stuff. And eventually what you're going to see over here is once it's finished, once we punch this button here for resume, it's going to actually run our code, and we should see it counting down from FFFF to 0 and stopping right on 0. And that's what we have to see to get your initial in the lab. So here we go. We're just going to hit this. And notice it's counting down from F, and I've got the count of 10. Notice how quickly that counts down. So if this is working properly, when we finally hit 0, it should stop right on 0. There we are. That's exactly what you need for your project checkpoint. Now I'm going to make one last change here because it mentions this in the lab. Let's go back over here, and what I'm going to do here is change this from being a long to an integer. And you had a pretty good idea of how long it took to count down. And the problem that you run into, and let me just do a quick build here. The reason for this is we've got an 8-bit microcontroller, And as you know, our longs are 32 bits, so if you've got 8 bits processing, it's going to have 4 times the amount of work than processing a char. So what's going to happen as you're doing this stuff, if you use a long variable, it's going to be 4 times as long as programming a char, but it's also going to be twice as long as processing an integer because it has to keep track of 32 bits as opposed to 16 bits. So it should be able to run a little bit faster. So when this thing is finished building here, what I'm going to do, I'm just going to switch over here to debug, and I'm just going to go to run and tell it to run. So when this thing is finished doing all of its initialization and stuff, watch over here and just see how fast this thing counts down and compare it to what we've seen before. And what you should see is that it's going to count down a lot faster. So here we go. Wow, that was a lot faster. And that was just changing something from long to integer. Now on a 32-bit machine, it's not going to really matter, but on an 8-bit machine, doing longs is going to take strangely enough, a long time.